Cable cross-sectional area in solar made simple. Let's talk about cable cross-sectional area, aka cable size. Because in solar, this wire will look small can cause big problem. For solar systems, especially panel to charge control or your hybrid inverter, wire sizing is not guesswork, it's calculation. And the formula engineers use is cable size, which is the cross-sectional area of the cable equals to 2 times L times I divided by 56 times 0.03 times V. Let me break it down, no fear. L is the cable length in meters, I is the current in amperage, V is the system voltage, and the 0.03 is the allowed 3% voltage drop applicable for panels to your charge control or 1% for inverter to battery or charge control to battery. 56 mm square is the conductivity constant for pure copper, while for aluminium is 30 mm. Now, the 2 is important because currents go and come back like Lagos traffic, front and back, and also considering the two wires live and neutral. Now, here's the truth. When you calculate this formula, sometimes the answer will give you strange numbers like 3.2 mm square or 7.4 mm square. But in real life, nobody buys 3.2 mm cable. In Nigeria and commonly among installers, the common usable cable sizes for DC connections are 2.5 mm square, 4 mm square, 6 mm square, and 10 mm square. So here is the rule of thumb every good installer should know. Always round up, never round down. It's very, very important. If calculation gives 2.8 mm square, use 4 mm square. If it gives 5.1 mm square, use 6 mm square. If it gives 8 mm square, use 10 mm square. Why? Because smaller cables means more heat, more voltage drop, slower charging, and eventually burnt wire. And I can tell you for a fact, you may likely get way above these numbers. Say you get 49 mm square at the end of your calculation. Use the divided by 5 rule of thumb. In this case, 49 divided by 5 is almost 10 mm. So use 10 mm. If your calculation is going way above this rule, you might want to reduce your current. Thank goodness we have high voltage inverters today. Adopt them. Also, some installers use this rule of thumb. If current is up to 30 amps, use a minimum of 6 mm wire. For a 40 to 60 amps, use nothing less than 10 mm wire. And for long distance connection, say 100 meters and above, or battery voltage setup, which are for home or mini industrial setup, stick to your 10 mm. Remember, panels don't burn system, undersized cables do. If your wire is eating up, your solar system is shouting for help, calculate it, round it up. Use original copper. That's how professionals do. Thanks for watching. Do like, share, and subscribe.